Hey everyone, and welcome to Chapter 7, starting our discussion about rational expressions and functions. There's a lot of fractions, a lot of variables, a lot of stuff going on, so we're really kind of diving into the belly of the beast, as it were. Let's recap what we mean by rational. So remember that a rational number refers to a number that is expressible as a ratio of two integers. There's an analog to this for polynomials. A rational expression is an expression that can be written as p over q. So basically, a rational number is a ratio of integers. A rational expression is a ratio of polynomials. And once you know what a rational expression is, you can define a rational function. A rational function is just a function defined by a rational expression. So a rational function is the ratio of two polynomial functions. Now, of particular note when we're talking about rational functions, which is kind of our focus here in this chapter, the domain of a rational function is always all the real numbers except for where the denominator is equal to 0. Because we know that division by 0 is illegal, right? So that kind of makes sense as to why that would be a domain restriction. We can't plug in any values that make us divide by 0. If we want to calculate the domain of a rational function, then basically what we got to do is set the denominator equal to 0 and solve it. So let's look at some examples. These are not terribly frightening. So like I said, we got to solve for when the denominators are equal to 0. So here, I'm setting 4x squared minus 16x minus 48 equal to 0. I notice that I have a GCF of 4, actually, so I can factor that out. And now I got to factor x squared minus 4x minus 12. Let's see, I know the signs are going to be different. If the signs are going to be different, that means that the difference of the two numbers that I pick have to be 4 in absolute value. So I know that 6 minus 2 is 4. So 6 and 2 will work. And then the minus sign goes on the larger absolute value. Scooch that over. So we have x minus 6 equals 0 and x plus 2 equals 0, giving us two solutions, x equals negative 2 and x equals 6. So this means that for r of x, the domain is every real number except for these two values, negative 2 and 6. And if I want to write that in interval notation, which I probably want to do, then if we think about it, having two numbers breaks my number line up into three pieces. Everything that's less than negative 2, everything between negative 2 and 6, and everything greater than 6. Of course, you have to combine those intervals with the union symbol. So that would be the domain in interval notation. Can do the same thing for t of x here. I have a GCF of 8, actually, so I'll factor out 8. And how does this factor? 8 times x. Numbers have to multiply to give me negative. Numbers have to multiply to give me 8. And their difference has to be 2 in absolute value. So it would be 4 and 2. Negative goes on 4. And x minus 4 is equal to 0, or x equals 4. And x plus 2 is equal to 0, or x is equal to negative 2. So t of x is defined at all real numbers except for negative 2 and 4, which, again, we want to write it in interval notation. So we need everything less than -2, everything greater than -2, but less than 4, and everything greater than 4. So that's a little bit about the domain of rational functions. What we're going to be focusing on, though, for the rest of this video is simplifying rational expressions, because they can get pretty gnarly to look at, so we want to know if there's a way we can make them look nicer. So when you simplify a fraction, if there are no common factors other than 1 in the numerator and denominator, you say that it's a simplified fraction. You have the same kind of idea for rational expressions. That is, a rational expression is simplified if its numerator and its denominator do not have any common factors, other than 1, of course. So this guy, x minus 8 over x plus 4, does not have any common factors, which would mean that this fraction is simplified. On the other hand, if I have something like 15x cubed over 5x, this is not a simplified rational expression, because I know that I have common factors of 5 and x. So this can be further simplified. X plus 2 over x, these two expressions do not have any factors in common, so I'm calling it simplified. And same for the reciprocal. Okay, so just because both the numerator and denominator have an x, there's no canceling going on, because you still have to account for that plus 2 that's in the numerator and denominator, respectively. Let's kind of dip our toes into the water with simplifying. To simplify a rational expression, we basically want to factor completely the numerator and the denominator, and that'll help us reduce the fraction, so to speak. Okay, let's see if I can't factor this guy. Upstairs, I have a common factor of 3, so I can actually factor that out. And downstairs, I have a common factor of 6. Okay, as a fraction, these coefficients reduce, so I actually would have just the 3 divides out to 1. I have a squared minus 4ab plus 4b squared over 2 times x squared minus 4b squared. And I have to completely factor the numerator and denominator to really know for sure if the thing is simplified or not. And I can tell you that this is not yet factored all the way. However, I do see that I have an a squared and a 4b squared. 4b squared is 2b squared, isn't it? And 4ab is 2 times a times b. So actually, the numerator is one of those special polynomials that we talked about, and hence it factors as a minus 2b squared. And if we look at the denominator, what do we have? X squared minus 4b squared. We just said that 4b squared is a square, so this is actually x squared minus 2b, whole thing squared, which is a difference of squares. Hey, okay. Now we're getting somewhere. We know how to factor difference of squares. It would be x minus 2b. I don't know where I got x from. Sorry about that. Right, a minus 2b and a plus 2b. And this reduces because one of these factors upstairs in the numerator can divide to 1. That would mean we have a minus 2b over 2 times a plus 2b. And that's it. We can't simplify it any further than that. Another example, okay, this one has x's in it, that's good. So to simplify this rational expression, we're going to start by factoring, which we're starting to get pretty good at. So upstairs, let's see, I have a negative here, which means the signs are different, and a positive here. So I need two numbers who multiply to give me 32, but whose difference is 4. Oh, 4 and 8, okay. And let's see, that sign is positive, so 8 gets a plus and 4 gets a minus. And on the bottom, I see that I have a difference of squares. So I already know how to do that. None of these factors are exactly the same. However, this guy and this guy are exactly the negatives of each other. So if I want to be clever, which I do, I can factor out a -1, and that would change the order around. Then I can reduce. So upon simplifying, you would have x plus 8 over the negative of 4 plus x. To simplify it maybe a little bit further, we want to distribute that negative again. And there we have it, a simplified rational expression. So that's all on simplifying. Now that we got that under our belt, we're going to look at multiplying and dividing rational expressions.